Good day, everyone. My name is Jill Cooley, and I'm currently a Senior Technical Advisor at the Y-12 National Security Complex in Oak Ridge, Tennessee. I recently returned from a 20-year assignment with the International Atomic Energy Agency in Vienna, Austria, where I was the Director of the Division of Safeguards Concepts and Planning in the Department of Safeguards, responsible for, among other things, strategic planning, the research and development program, development of new concepts and approaches, quality management, and the training of inspectors and state authorities. I'm very honored and pleased to be here today to talk to you about one of my favorite subjects, the safeguards work of the International Atomic Energy Agency. What I'd like to first do is give you a quick snapshot of the work of the IAEA and then focus on the nuclear verification activities, highlighting a number of the challenges that have arisen over the years and how the IAEA has addressed them, strengthening the safeguard system. The International Atomic Energy Agency is an independent, international, science and technology based organization that is the global focal point for all nuclear cooperation. It was established in 1957 with its headquarters in Vienna, Austria. It employs some 2,500 people, most of them located in Vienna, but the IAEA also operates laboratories in Seibersdorf, Austria, outside of Vienna, and in Monaco, and has field offices in Toronto and Tokyo. The mission of the IAEA is to promote the safe, secure, and peaceful use of nuclear technology, and to prevent the proliferation of nuclear weapons. Quite a tall order on both accounts. A core activity in this regard is the promotion of peaceful nuclear applications, in particular to developing countries. For example, using radiation to accelerate genetic mutation of crops. Here's an example of a drought-resistant rice strain. To use radiation for insect sterilization for pest control. The IAEA had a very successful tsetse fly eradication program in Tanzania. And to provide cancer therapy units at cancer clinics around the world. Another core activity is in nuclear safety and security, the provision of safety standards for the operation of nuclear facilities. The IAEA installs detection equipment at borders of states to help detect illicit trafficking of nuclear materials and other radioactive sources. And the IAEA helps countries that are hosting high-profile events with their security plans. Now, the third core activity is the safeguards verification work. But to understand this, you have to see the safeguards activities in the context of the whole nuclear non-proliferation regime, which has a number of important elements. The first of which is all the global, regional, and bilateral agreements where states make commitments not to further the spread of nuclear weapons. And the IAEA Safeguards is used to verify that states are in compliance with these commitments. A second important element is the export control regimes, where the suppliers of nuclear-related material, technology, and equipment agree to the provisions for the sale or providing this equipment or material to states. And the third important element is physical protection, which is under the purview of states and facilities themselves to make sure that the facilities are protected against the seizure, theft, and other malicious activities involving the nuclear material or the facility itself. Now, the centerpiece of the nuclear non-proliferation regime is the Non-Proliferation Treaty. With 191 state signatories, it's the treaty that's the most widely adhered to treaty in the world. The 185 non-nuclear weapon states that have signed this treaty have agreed not to pursue anything nuclear weapons related with the full access to peaceful uses of nuclear energy in return for access to peaceful uses. The non-nuclear weapon states have to place all of their nuclear material and activities under safeguards. The 5 nuclear weapon states that have signed the NPT, that is China, France, the Russian Federation, the United Kingdom, and the United States, have made a commitment to pursue nuclear disarmament. Now let me just give you a snapshot of the various legal instruments that exist under which the IAEA conducts its activities. The most common is the Comprehensive Safeguards Agreements that are concluded by all the non-nuclear weapons states that are party to the NPT. This is in connection with the NPT itself, a requirement, as well as a number of the nuclear weapon-free zone treaties. Many of these non-nuclear weapon states have very small quantities or perhaps no nuclear material or activities, and they are allowed to conclude with their safeguards agreement what's called a small quantities protocol that simplifies the application of safeguards. The 5 nuclear weapon states have all concluded what's referred to as voluntary offer agreements, where they place some or all of, or make eligible for safeguards some or all of their civilian nuclear activities, programs. And then there are item-specific safeguards agreements. These are concluded by the 3 states that have not signed the NPT, that being India, Israel, and Pakistan. And so these are agreements that place certain restrictions on their use of this nuclear material or activities or equipment that has been provided. And then the last instrument, very relatively recent but very important, is referred to as the additional protocol. And this is available to all states with the safeguards agreement. It's concluded on a voluntary basis, but once a state has agreed to conclude one, it becomes part of their safeguards agreement. And this requires the provision of more information and allowing the IAEA to access more locations in the state. And I'll describe that later. Now, safeguards implementation itself is governed by the IAEA's and states' rights and obligations that are contained in the safeguards agreement that's concluded with the state. And basically, safeguards are the technical means for verifying that states are in compliance with their commitments. Under a comprehensive safeguards agreement, the IAEA has the right and obligation to ensure that safeguards are applied on all source or special fissionable material to ensure that this material has not been diverted. And under the voluntary offer agreement and an item-specific safeguards agreement, safeguards are applied to specified material and items. So let me cover just a bit more of these agreements. So the comprehensive safeguards agreements, as I said, are the most common. Currently, they are in force with 174 states. There are 10 states that have signed the NPT that have not yet concluded one of these as required. And more than half, 95 of them, have the small quantities protocol that, as I indicated, simplifies the application of safeguards. The 5 nuclear weapon states have the voluntary offer agreements. And the IAEA does relatively little in these states. In the United States, for instance, there's only one facility where safeguards is currently being applied. That's at the MOX facility in Savannah River. And then, as I mentioned, the 3 non-NPT states have various item-specific safeguards agreements. So let me go into a little more detail on IAEA safeguards. Basically, the purpose of safeguards is to provide assurance to the international community that states are in compliance with their obligations for exclusively peaceful use of nuclear material and their nuclear facilities. The goal of safeguards from a technical side is to detect in a timely manner any diversion of nuclear material and to deter this diversion through the risk of early detection. And the specific task is for the agency to verify what's referred to as the correctness and completeness of the declarations that are made by states. And this term, correctness and completeness, is very important, and I'll come back to it. It refers to not only verifying that what a state has declared is accurate, but that they've also declared everything. Everything that's supposed to have been declared has been declared. This is, again, as I'll describe, a pretty tall order. So where is this nuclear material? Obviously, it's in the main facilities associated with the nuclear fuel cycle. Here's just a schematic. Mining and milling, conversion, fuel fab, enrichment reactors through to reprocessing and storage. But also, there's nuclear material that's located, small quantities of nuclear material can be located in hospitals, in research centers, in laboratories, even in industry. And all of this material is subject to safeguards. When we look at safeguards under a comprehensive safeguards agreement, the focus is to ensure that this material is not diverted for use in a nuclear weapon or other explosive device. So the focus of activities is looking at how a state can acquire direct use material, that is high enriched uranium, HEU, or plutonium. So if we look at under a comprehensive safeguards agreement, the main activities from a safeguard standpoint start somewhere at the conversion step and go through to reprocessing, as well as these locations with small quantities of nuclear material. So that's the focus of activities. Now, there are definitely some limits of what's referred to as traditional safeguards. So if we look at safeguards before 1991, the focus of the activities was on declared facilities and nuclear material, basically to verify the correctness of the material, the declarations made by states to ensure that there's been no diversion. And there was very little attention paid to these small quantities of nuclear material. And as I indicated, this basically provides assurance that regarding the correctness and a very mechanistic approach. The IAEA had criteria that described how many inspections, at what kind of activities at each of these facilities. And there was very limited possibilities to detect undeclared activities elsewhere in the state. And the whole premise of this approach was that a state was going to declare everything. And of course, this whole model went out the window with the discovery of Iraq's clandestine nuclear weapons program in the aftermath of the first Gulf War in 1991. So here we have just a simple schematic of one of the large research sites in Iraq, Tuwaitha. These red buildings indicated on this schematic is where the IAEA was doing safeguards. These were the declared facilities, a fuel fabrication lab, and 2 research reactors. The IAEA was going. Iraq had a comprehensive safeguards agreement in force. The IAEA was making conclusions, drawing conclusions each year that the declared nuclear material remained under safeguards. And of course, after the Gulf War, when the UN inspectors went in, found all kinds of undeclared activities on this same site, ranging from metal production to laser enrichment to UF4 and UF6 and preparation and reprocessing. All of these activities should have been declared. It was all focused on the and the IAEA's activities at this site were only to the red buildings. They had no access to these other buildings. Now, this is, of course, one of the main things that was happening in the early 90s, but the IAEA also faced a number of other challenges. In the early 90s, the Soviet Union dissolved, and the former Soviet Union states signed the NPT, which placed a lot of new facilities and material under safeguards, so the workload of the IAEA increased substantially. Undeclared activities were discovered in North Korea. Again, North Korea had a comprehensive safeguards agreement. And with the use of environmental sampling and satellite imagery provided by a third party, the United States, it was clear that North Korea was in non-compliance with its safeguards agreement, and that problem is still existing to date. Another activity that was occurring in the early 90s, another event, was South Africa gave up its nuclear weapons program and signed the NPT. And the IAEA had the task of verifying that the initial nuclear material declaration of South Africa was correct and complete. And this was a very positive experience because South Africa was very cooperative. So all of these events set the stage for the international community really supporting the need to strengthen the IAEA safeguard system. And so a number of measures have been put in place over the years, which I'd like to highlight. For example, in 1996, environmental sampling started being used as a technical tool, a very important tool to detect undeclared activities, and I'll describe that a bit more. In that same year, the IAEA started what's referred to as state evaluation, using a broad range of information available, safeguards relevant information available to the agency to be able to look at a state's nuclear program and make determinations of correctness and completeness. And here one has to consider, again, what was happening in the mid-90s, and that was the internet came into play. And so making much information much more available and accessible to the IAEA. And I'll describe that. I mentioned the additional protocol, a new legal instrument. The IAEA Board of Governors approved this in 1997, and many states have signed and brought into force an additional protocol. In 2000, the IAEA started implementing what's referred to as remote monitoring, where they install Safeguards equipment in nuclear facilities where it operates unattended, and the data from those pieces of equipment is transmitted to headquarters, to the IAEA headquarters in Vienna for evaluation. In 2001, the IAEA established a satellite imagery laboratory, and now that's also a routine activity supporting its work. In 2005, in response to the revelations of the clandestine supply networks, the AQCON network, for equipment and nuclear material, the IAEA started looking at trade information and trade data, and so established that capability within the Department of Safeguards. And also that same year, that small quantities protocol that I referred to, that some 95 states have with their comprehensive safeguards agreement, it was modified to allow the IAEA to actually conduct inspections in the state. And for the state to provide a bit more information, again, to strengthen. And so the whole message on this slide, and I'll get into more detail, is that the IAEA's safeguard system continually evolves to take advantage of new technologies as it becomes available, to address the various challenges as they arise, and to take advantage of the experience gained in its work. So let's focus on this verification work. In a snapshot, the IAEA is currently applying safeguards for 182 states. There's a lot of nuclear material under safeguards, over 193,000 significant quantities. Basically, a significant quantity is the approximate amount of nuclear material required to make a nuclear explosive device, so basically a bomb's worth. In the Department of Safeguards, there's some 250 full-time inspectors doing inspections and doing evaluations. As well, there's about 150 additional professional staff within the department that can act as inspectors for backup. So these inspectors conduct over 2,000 inspections in a year, 1,300 facilities and other locations. Thousands and thousands of seals are applied and verified. Samples, both physical nuclear material samples as well as environmental samples, and some 400 satellite images are procured and analyzed. Along with these inspectors and other professional staff, there's a total of about 800 staff in the Department of Safeguards involved in conducting all these assessments, these evaluations, and the final result is drawing safeguards conclusions for the international communities. So let's look at the evaluation to draw these safeguards conclusions. And what's important is that the IAEA draws upon a whole host of information, safeguards relevant information that's available to it. First of all, there's the information that states are required to provide either under their safeguards agreement. So they have to provide information on their nuclear material holdings and all the transfers of nuclear material. As well as information about the facility's design and how it processes this material. If a state has an additional protocol in force, there's additional information that needs to be provided. And then the states, many states provide additional information on a voluntary basis that's not required by their safeguards agreement. And this is important information. The second category of safeguards relevant information is the information that the IAEA generates from its own verification activities, whether that's in the field or at headquarters. So that includes inspections, design information verification. The state has an additional protocol. The access provisions are called complementary access. And then there's headquarter evaluation activities that also generate very important information and data for the IAEA to evaluate. And then the third category is other relevant information. So this can be from a whole range of open sources, various publications, technical publications, satellite imagery, as well as other internal reports of the IAEA and information from other states or organizations, third-party information. So let's look at some of these activities. First and foremost, a fundamental measure of safeguards is nuclear material accountancy. Here, as I indicated, the states are required to declare their holdings of nuclear material and all their movements, whether that be within a facility, between facilities in the state, or between states themselves. So inspectors go into the field. They do audits of the records. They make sure that the facility records are consistent with the state reports that have been sent to the IAEA headquarters in Vienna. Inspectors also go into into the field and count items and identify it to verify against the records, and will conduct some independent measurements, non-destructive assay, as well as the taking of physical samples. And of course, the IAEA isn't there all the time. It only goes periodically, and it can't repeat all these measurements. So what it does in terms of its activities is it's determined on a statistical basis based on what kind of facility it is and what kind of nuclear material. And the whole purpose of nuclear material accountancy is to verify the correctness of the state's nuclear material reports. So here's some pictures of inspectors in the field. Pictures of inspectors counting and identifying fresh fuel at a power reactor, comparing it against the reports. Here's examples of non-destructive assay measurements, looking at spent fuel in a reactor pond, conducting measurements of fresh fuel, as well as doing some weighing of cylinders to check these state records. Here's pictures of sample taking, actual physical sample fuel pellets, some powder, and this material is then sent to the IAEA's laboratory in Seibersdorf, Austria for analysis. Another fundamental safeguards measure that's used at facilities is referred to as containment and surveillance. So this is basically the use of seals and cameras to maintain the continuity of knowledge of the nuclear material, as well as ensure that equipment isn't being tampered with. And the IAEA has a whole host of range of cameras and seals it uses. Again, some pictures, surveillance cameras being serviced at a reactor fuel pond, the sealing of a transport cask before the shipment leaves the site, and then it'll be verified at the receipt location. I've mentioned remote monitoring, that the IAEA established this capability in 2000. So the IAEA installs a range of cameras, electronic seals, as well as radiation detectors. And the data from this equipment is collected in a local computer, and then periodically, whether it be daily or every couple days, it will be uploaded either by satellite or by internet to the IAEA's headquarters or one of its field offices for review. And this is a very important element because what remote monitoring allows is the safeguards information to be collected continuously. So instead of waiting for inspectors to go quarterly or semi-annually to a facility to look at the data being collected, this data is available continuously. So clearly strengthens it, safeguards, and is an efficiency measure because it then allows the IAEA doesn't have to go to the facilities as often. So currently, this is the current status as of last year, some 285 systems have been installed in some 23 countries, lots of surveillance systems with hundreds of cameras, as well as a number of radiation detection systems and a couple hundred seal arrays. and approximately 4 to 5 gigabytes of data are sent to headquarters on a daily basis. On the other side are some pictures. The first is the remote monitoring lab in the Department of Safeguards, and this shows the status of all 285 of those systems. It continuously monitors the state of health, and so if there's some indication that something is going wrong in the field, the IAEA can send a technician or inspector to fix it promptly, as opposed to waiting till the next inspection. Also, a very cool capability is that with the new generation of cameras that are being installed, the IAEA can actually change the field of view, can change where the camera is pointing in the field from Vienna, as well as change the picture-taking interval. So for instance, maybe the picture-taking interval at a static storage is, or spent fuel pond, maybe every 30 seconds, and if there is notification from the operator that he's going to start moving some spent fuel, then the IAEA can change, perhaps will want to change it to on the order of 6 to 10 seconds to be able to observe all of the motion and activities going on. The middle picture there is a picture of a satellite relay station on top of one of the IAEA's buildings in Vienna. As I mentioned, there are some locations where the internet doesn't work very well, and so the IAEA has then used satellite connection. And in fact, that last picture on the bottom is from Chernobyl, where the agency had unattended equipment with the data being transmitted by satellite to Vienna for review. Another very important technical measure that the IAEA uses, and this capability was established in 1996, is environmental sampling. And environmental sampling is based on the premise that no matter how leak tight an operator tries to make his or her system, small amounts of nuclear material will always leak to the environment. Now what we're talking about is very small quantities that are below concern from a health and safety standpoint. But the key here is that there are techniques available to be able to detect these very low-level particles that are in the environment. And this technique is key for being able to detect possible indications of undeclared nuclear material or activities. So as I said, implemented as a routine measure 20 years ago. Currently swipe samples, so that's the main kind of sample that's taken, just basically a dust sample from equipment or infrastructure. And these samples are taken during inspections, during design information verification, as well as during complementary access. And key to this whole technique is that the IAEA has a network of laboratories that are able to do these very low-level radiometric and isotopic measurements. Currently, there are 21 laboratories in 9 member states of the IAEA, as well as in the European Commission, the Transuranium Institute in Germany, and the IAEA's Safeguards Analytical Laboratory in Cybersdorf. The U.S. has a number of laboratories, and Oak Ridge National Laboratory is the focal point for the U.S. labs. Another very important in-field activity is called design information verification. And this is done basically at the start of construction of a nuclear facility, and it's conducted throughout the entire life cycle of a facility until it's decommissioned for safeguards purposes. And the purpose of design information verification is to ensure that the appropriate safeguards measures are being applied at a facility. And this is not a one-time event. As I said, it starts with the construction as the approach is being developed by the IAEA for safeguards, and then it's done throughout the lifetime of the facility to ensure that the measures remain relevant, as well as to detect any potential misuse of a facility. The new legal instrument that came into play in 1997, referred to as the Model Additional Protocol, as I said, is open to all states with the Safeguards Agreement. For a comprehensive safeguards agreement state, the state must accept all the provisions of the additional protocol. They can't pick and choose various measures. Whereas for states, the nuclear weapons states, states with voluntary offer agreements and the item specific, they choose things that are appropriate for their individual states. What's important to recognize is that the information and access that is provided under an additional protocol doesn't repeat anything that's required under a comprehensive safeguards agreement. It basically fills the gap of information and access to get a better picture of a state. And the measures provided in an additional protocol significantly increase the agency's ability to verify this correctness and completeness of a state's declarations to get a completest picture as possible of what a state is doing. And as of the end of last year, 126 states have additional protocols in force. So there's still a few holdout states, but a significant number of states where this is being implemented. So let me just describe some of the key features of the additional protocol. As I said, it requires the state to provide more information. This includes mining and milling activities at the front end of the fuel cycle. Very important is to provide information on nuclear fuel cycle research and development that doesn't involve nuclear material, so this isn't required under a comprehensive safeguards agreement. Information on the manufacturing of sensitive equipment, so single-use equipment, as well as exports. And it also includes providing information on future fuel cycle plans. And again, this is a focus on trying to get as complete a picture as possible of a state's nuclear program. On the access side, the IAEA is allowed to go to any location on a site on short notice. So think of that picture I showed you on Tuwaitha, where the IAEA was only focused on the few buildings that were declared. With an additional protocol, the IAEA could go to any of the buildings on that site. Other declared locations in the state, so there's provisions for going to R&D centers, manufacturing centers, that's with a 24-hour notice. And then the IAEA can also go to undeclared locations based on information specifically to do environmental sampling. And then there's also a number of administrative measures, a simplified procedure to designate inspectors, as well as the provision that the state needs to provide multi-entry visas so that the IAEA doesn't have to request a visa every time it wants to access the state. In addition, under an additional protocol, the IAEA can request amplification and clarification of declared information, and this is a standard thing. There's always questions on what a state has provided, either due to mistakes or translation issues, so the IAEA can go back to get more information. If it has questions and inconsistencies that arise during the evaluation and comparison with other information, it also can go back to the state. And then get some more information on facilities themselves to improve safeguards. So perhaps quicker notice of refueling events or outages at facilities that the state will provide. And then additional important provisions is the state can request what's called managed access if there's issues with regard to safety or security or non-proliferation. It can agree with the IAEA to restrict where the IAEA can access. However, the IAEA always has to be able to meet its objectives, so it's a negotiation process. The IAEA, states can also offer the IAEA to come anywhere in the state, and this has been done by a number of states. There's also a provision for, I like to call it a placeholder for the possibility to do wide area environmental sampling. The IAEA, the environmental sampling that the IAEA does currently is called location specific, so it's at an actual facility or a declared location. And so this is the possibility to perhaps put in place in a future time a wide area network. And then there are annexes in the additional protocol where the state has to provide information on manufacturing locations as well as exports. And these annexes can be periodically amended with universal effect. So the state doesn't have to approve it. Once it's approved by the board, it will go into effect for all states. That hasn't been done to date yet. So if we go back to this picture on safeguards coverage, this is our fuel cycle picture, and this is the one showing in red where the focus is under a comprehensive safeguards agreement. With an additional protocol, now the IAEA has information on the front end of the fuel cycle, so the mining and milling, on the back end in terms of storage, but also very importantly information on nuclear-related infrastructure, so this R&D and manufacturing locations, as well as heavy water production. So again, trying to complete this picture of what a state's nuclear program entails. The third category I refer to is this other relevant information, and so I said the agency draws on a whole host of open sources, so this can include annual reports from facilities or regulatory agencies, scientific and technical literature, a very important source of information on states' programs, nuclear programs, patent databases, trade publications, just general media. I mentioned trade-related data that started being gathered in 2005, and satellite imagery, taking advantage of both free services, Google Earth, as well as procured. And here let me focus a little bit on this commercial satellite imagery. As I indicated, a lab was established within the Department of Safeguards in 2001, and currently high-resolution commercial imagery is being acquired from some 22 different Earth observation satellites through commercial providers, so the IAEA has contracts with these commercial providers, and it gets it procures both optical imagery as well as radar, thermal, and panchromatic, and it's expanding its capabilities in all regards. And since the IAEA started doing this, it's just incredible how the resolution has improved tremendously. When the IAEA first started using satellite imagery from commercial providers, the imagery was just under a meter resolution. And with the latest satellite, I think it's a U.S. satellite that went up last year, commercial imagery is now way below a half a meter, like on the order of a foot resolution, which is unbelievable, just fantastic. And so in 2014, the last year I have data for, the IAEA acquired and analyzed some 400 images. And this imagery is useful from various standpoints. That picture on the bottom there shows an application where the IAEA can look at site drawings and see if a state has actually declared all the facilities on a site. Site drawings are required under an additional protocol, so there's a tool where they can overlay a drawing with an image and see if there's buildings outside the site or buildings that the state, in most cases, inadvertently failed to declare. And this helps the IAEA inspectors plan their inspection activities. You can imagine if an IAEA inspector went to a research site that had some 300 buildings and the inspector walked in the gate with the map, it would be pretty hard to determine if everything was located. So they start by doing an image. Imagery is also used to check mines to see if they're in standby status as declared or if they're operating. Mines are located in pretty remote areas in the middle of Australia and the northern parts of Canada, and it's very difficult to get to these locations. So the agency has learned that imagery is a very useful tool in this regard, as well to look for undeclared activities, undeclared facilities. Another type of other relevant information is third-party information, and this is described as information that's made available to the IAEA by a state or other party, an organization or an individual, on a voluntary basis relating to another state. And so this includes nuclear procurement-related information. The IAEA has arrangements with a number of states where they will provide information on procurement attempts, individuals or entities trying to procure something, or export denials of nuclear material or equipment. And again, this is very important from trying to look at the possibility of clandestine activities if a state is pursuing some clandestine activities. Third-party information is also information that's collected through national means, basically intelligence information. And this information might suggest the possibility of undeclared nuclear material or activities in a site. This isn't a huge source of information, but it's a very, very important source of information. And it has provided the agency, the IAEA obviously has limited resources, and so it relies on its member states to help it with information collection. Okay, so I just described all this information, all this collections, and the whole key is to put this all together, to analyze it. So to analyze all these bits and pieces of the safeguards relevant information and draw a picture about a state. And this is what's referred to as the state evaluation process. This is just a simple diagram. It's supposed to convey that it's a continuous process. So the collection and evaluation of information doesn't have a starting point or end point. The IAEA is always collecting information that the state provides from its activities, as well as other relevant information. And this information is used to plan safeguards activities, to decide what the IAEA is going to do, to conduct its activities, whether it's in the field or in headquarters, and then to start the cycle, continue the cycle in analyzing all that information. And periodically, on an annual basis, the IAEA draws safeguards conclusions for each state that has a safeguards agreement in force. And this is reported to first the IAEA's Board of Governors in an annual report called the Safeguards Implementation Report. This is a report that goes to the board in May of every year. And then once the board takes note of the report, the conclusions get released to the international community. And again, this is ensuring the international community that states are living up to their non-proliferation obligations. And this state evaluation is conducted for each state with a safeguards agreement in force. And as I said, it provides the basis for the annual safeguards conclusion. Now, that's a description of what happens when everything works well. And of course, there have been over the years and continue to be a number of state-specific challenges. And just to highlight a few of them, North Korea, the IAEA discovered clandestine activities in the early 90s, as I indicated, and the North Korea subsequently unilaterally withdrew from the NPT. And the IAEA hasn't done safeguards verification activities there for many, many years. There was some activities in the mid-2000s when there was the six-party talks going on, and so there was some verification work, but the IAEA hasn't done anything for over 5 years. The IAEA continues to collect information on North Korea in hopes that North Korea might decide at some point to rejoin the NPT and put its safeguards agreement back in play. Of course, since then, the DPRK has announced 4 nuclear weapons tests just recently, the 4th one. And so this is a deep concern for the international community and the IAEA. Syria. In 2007, Israel bombed what it said was a nuclear reactor. In 2008, based on information provided by third parties and inspections by the IAEA subsequently determined that it was most likely a nuclear facility that should have been declared. Syria was found to be in non-compliance and asked to provide information, which has yet to do. The IAEA does inspect a few facilities there, but over the last couple of years, due to the security situation, which is also a big challenge in a number of countries, the IAEA hasn't done any inspections in Syria. And of course, Iran, I could do a whole talk on Iran itself. Iran was found in 2004 to have been undeclared activities for the previous 2 decades. And of course, there's been a lot of activities over the last 10 plus years to try to get information and to strengthen safeguards being done and verification activities in Iran. And so last summer, finally the comprehensive joint plan of action was agreed with the parties, the 6 parties in Iran. And the IAEA has just released in December its report on the possible military dimensions of Iran, which sets the stage for implementation of the plan of action, comprehensive plan of action, and the lifting of a number of sanctions in Iran. But it's still an issue that will require quite a bit of work. So just to summarize some of the current and future challenges to the IAEA, I've put at the top of the list the monitoring of the Joint Comprehensive Plan of Action. This will be a multi-year activity that requires and has been and will require a lot of resources within the Department of Safeguards. The second challenge, while the IAEA has the world's attention with regard to Iran, it also has 180 other states that it has to do safeguards for, and so it'll be a great challenge to continue to provide credible assurances regarding exclusively peaceful use with the increase of nuclear material and facilities coming under safeguards, and looking at the budget, which has basically been static for many years. The latest number I had in 2014, 124 million euros of a regular budget and a heavy reliance on extra budgetary contributions. And just to put it in perspective, the athletic department budgets of many top universities, including the University of Tennessee, is on this same order of money. And so here the IAEA is conducting its safeguards activities with the budget of a large athletic program, so quite a tall order. Another challenge will be safeguarding advanced technology types. There's new facilities being built, geological repositories. Sweden is building one, Finland is building one, and Sweden has got one ready to be built. Laser enrichment, new technologies, pyroprocessing. So the IAEA has challenges in developing effective approaches for these types. Country-specific issues, I've already mentioned Iran, North Korea, and Syria. Security-related issues. This is really becoming a big one, both from the physical access standpoint. I mentioned Syria. The IAEA hasn't conducted inspections there in years. Same goes for Libya, Ukraine with the Crimea situation. So the IAEA does not put its inspectors in harm's way, and so these are challenges to be able to continue to implement its safeguards when the inspectors don't have access. And ISIS as well, providing issues. And then cybersecurity, that's also another challenge in terms of the IAEA's databases internally, as well as its equipment that it uses in the field. And then another possible challenge is maybe the IAEA will have a potential future role in disarmament verification. As I indicated, the 5 nuclear weapon states have made a commitment under the NPT to pursue disarmament. This has been a topic in the latest NPT review conferences, the latest one being last year, where the non-nuclear weapon states definitely want to see some movement toward disarmament. And, and the IAEA has a potential role in being a verification arm in future treaties. So in conclusion, safeguards implementation, I want to get across the point that it continuously evolves. Safeguards is not a static thing. It evolves to address various challenges, which seem to always arise, as I indicated, to take advantage of new technology and techniques and to incorporate lessons learned. The additional protocols that are concluded with states, in particular with Comprehensive Safeguards Agreement states, provide the IAEA with essential tools to verify the correctness and completeness of states' declarations. Without an additional protocol, the agency only draws conclusions on correctness of states' declarations. And also very important, and the IAEA continues to look at how to expand safeguards relevant information. It uses all available safeguards relevant information to evaluate state and its nuclear program as the basis for drawing safeguards conclusions. So with that, I look forward to your questions and answers in next week, I believe, and hope you have some good ones. I'm very anxious to entertain any questions. Thank you.